So just to give you a brief introduction, we'll talk about the AI-based condition monitoring and preventive failure analysis. There is a lot of discussion of lately that you hear about the use of AI and how we can actually benefit from that, and that is what we've been working on. And we'll give you some real example of how we are taking an advantage of the upcoming technology. So just a brief overview that COMARK has been in business for 50 years now. This is our 50th anniversary. We are based in New England area, outskirts of Boston. And we primarily serve three industries: aerospace and defense, fire life and safety, and industrial automation. But the takeaway from the industry that we serve is that we are on mission critical applications. So it's application that needs very high reliability, all kinds of certification rigor, any sort of custom engineering, any sort of code design with our partners or customers is where we shine. We have millions of devices that are deployed worldwide. And we are a division of a company called Source Code. Source Code is also headquartered in Massachusetts. Source Code provides all kinds of IT hardware, large racks to any sort of storage solutions to you name it. And Source Code is a global company. I know this is not about the company presentation, so I'll quickly switch over to condition view. What is condition view? So we are developing this AI-based technology, and that is for mission critical applications. What it does is it provides a comprehensive monitoring and of all the software and the hardware that is running on any kind of a computer or a display. And the purpose of this monitoring is to provide foresight into the systems that provides you the failure reports, information of maintenance requirements, any sort of a component degradation that could lead into a system failure. And I'll give you some examples of that as we go along. But after you do this monitoring, how do you access this information? So this information can be accessed on multiple platforms. It could be on your cell phone. It could be in the control room. It could be it could be displayed on anyone's desk who's monitoring the plant, for example. The whole thing is based on IoT that collects the data, it transfers, and it shares the analysis. And also it also can provide you any smart alerts, that is through emails, SMS, etc. So there are multiple ways you can get notified of any conditions that are normal or abnormal that is happening in the system. Then this leads us into a predictive failure analysis. And predictive failure analysis is AI based. It analyzes the information to predict the failure that could be happening in near future, and that provides you an ability to do a proactive maintenance such that you can avoid downtime. A critical piece of equipment does not have to fail or does not have to go down. It does not have to take the process. Because in many of these cases where mission critical piece of hardware or a software that goes down, it could create lots of problems, lots of issues. And of course, you have to worry about the data security, because now all this information that is going, how do you manage that data security? So it is on a secure platform. So how does this AI enhance this condition? What we talked about it is It detects anomalies and provides actionable insights into the failure that could be happening. So you can prevent downtime. You can also do proactive maintenance. It could be a piece of hardware that could be happening, such as, let's say, as simple as the fan speed is degrading, and you are able to see it, and you are able to take a proactive action against that. It provides you a comprehensive system health view, such as is your CPU percentage or CPU's usage going beyond, which is going to slow down your processes. Are the power supplies that is providing basically all the critical power to the system, are they operating in a safe zone, safe margins? As simple as your SSD health, like, you do have too many retries. Is that your SSD is getting overused, or it is coming to end of life in terms of the reliability? Also provides you predictive analysis that can tell you what could be happening in future. And for future enhancements, it basically is what we discussed, or what I explained earlier. That is providing the data security, so you can also do any sort of threat detection. You can safeguard your system from any such attacks. And how we achieve that? So you ask the question, what does it do? What is condition? What's in it for me? What's in it for business to do that? So along with offering the real-time and precise information, the biggest thing it does, it gives you a proactive method of solving the problem before it really happens in the field. It minimizes your downtime. It improves your response time. That is, rather than being reactive, you can be proactive. And at the end of the day, it improves customer satisfaction because your uptime being high. You don't need to bring your systems or processes down just for the maintenance. Okay. Continuing on to the next slide. Don't try to read too much into it. I'll go through some of these details some of these blocks in a greater detail, but effectively look at it as it is the three major blocks. That is, towards the bottom, what you see is all the hardware that is acquiring the information, all the sensors that is acquiring the information about what's happening. Through the API, it is sending that information over to the tools that can basically detect and predict any of these and report any of these conditions that are happening. Okay, and I'll go through some of these blocks in greater detail. In terms of what kind of things that we are monitoring for the hardware as well as the system. When it comes to hardware, we are monitoring power supply voltages and currents. We are maintaining the core voltages of the critical components, SBC being single board computer. So any of these computers that have core voltages, we are monitoring that, as well as some of the battery voltages that are required for CMOS, that is maintaining real-time clock. Again, these are all required for critical operation of the systems. We are monitoring fan speed if it is applicable. Some of the systems are fanless, but if you happen to have a fan, we are monitoring the fan speed. We are monitoring CPU usage, making sure that the system is not getting overloaded, such that your critical processes could not respond as you anticipate it to respond. We are monitoring memory pool and the usage, and the same reason for that you don't want your critical processes to be slower in responding. We're monitoring SSD, which is basically your storage devices, through smart parameters and wear out and restarts. And wear out and restarts are critical because you only have certain amount of spare capacity for these wear outs. And once it gets to that level, basically you would have um, outlived the life of SSD, and that could lead into a fail. Similarly, CPU uses CPU core and utilization, GPU utilization, any other critical chipsets that are on the computer. We are monitoring that. Any of the other internal systems, and systems being any of the other critical I/O that can be monitored. If you have a UPS in the system, when the UPS being the power supply, you can monitor that. And we are also monitoring all kinds of peripherals, LAN, serial, USB, and other things. And at a system level, we are monitoring uptime. What is the total hour the system is being operating for? How many unexpected and expected restarts are happening, manual restarts, because that's also an indication that there is some problem in the system. The BIOS version, critical to know that if you don't have, or somebody did not, or somebody updated the BIOS, which is with incorrect version, that could lead into a system failure or unreliable system operation. Second thing would be any of the operating systems and making sure that we are using the right version with the right security patches, many critical drivers and their versions, and critical event logs that are being produced by operating systems, and that could be indicating problems or issues. We're also monitoring a bunch of environmental conditions such as temperature, humidity, shock and vibration, filter clog if there are filters used for fan, any sort of a smoke or a dust detection in the system. And the architecture is flexible enough where we can add other sensors based on the application or based on the system. So that is also the flexibility as well as the future expansions is also factored into the design. And as I promised, I'm not going to, I did not want you guys to focus on that one page that had a lot of details, but I'll take individual sections. So when it comes to hardware, what you see on the top left is an example of epic form factor computer, and that computer itself has sensors that are monitoring critical parameters such as CPU core voltages and currents that are being consumed by the system. So I'll give you one example that let's say this computer, when it started, it is consuming certain amount of power. Then as the usage continues, let's say there was some impending failure or there was a lifetime where components started to degrade. And now all of a sudden you are seeing differences in terms of the voltages or currents. That's an indication that things are starting to go bad. And you don't have to wait until it goes bad. You can do a proactive action. That's one example of that. The system is designed where you can also put an independent external hardware monitoring that, let's say the system is down for whatever reason. Now you have a parallel backup system that can at least provide you the status of the system. So it's not that the system is completely blind, completely dead, but you can query about the system through this fault-tolerant, independent processor that can provide you live update of what is happening. And the sensors are on I2C bus. So there is a small typo, ignore that for reason, for the time being. But there are various sensors that are all flexible on the full I2C bus, and you can easily expand. And you can put n number of extra sensors if needed. In fact, the whole architecture is developed such that even if you don't have very customized hardware, just like the single board computer that you see on the top left, you can still deploy these sensors as well as the a standalone board, a standalone embedded board that can provide you all kinds of system monitoring, and it could be anything. It doesn't have to be just our system. You can deploy that into any of the critical machinery, and it will still do the same thing. For single board computer, all these sensors, they are embedded on the boards, so it can do the board level detection. And for environmental, they are on I2C. That's where you can integrate into any system. It can be a standalone product into or part of our system. It doesn't have to be completely embedded into our system. When it comes to the system level software, it's Windows and Linux compatible. It interfaces with the CVM hardware. It requires local system data, local sensor data, sorry, and it collects the system data, what we explained earlier, disk storage usage, CPU usage, motherboard, drivers version, etc. And then it passes on to the platform, to the higher level platform. And when it comes to the higher level platform, this is where you can come up with the dashboard, utilization, and notification. It can provide all kinds of monitoring up in the cloud, or it can be behind the firewall. It provides like there is a dashboard, and I'll explain what the dashboard looks like later on. Gives you the visualization, gives you a notification. Notification come through SMS or emails or any other way. It is platform independent, and the connectivity is secure. And when it comes to the predictive failure analysis, right now the platform is, we are working on the final platform. It can be Azure, it could be vSphere. And this is one of the things that we are also talking. We are looking at CODESYS as an overall software where this API, we can provide that on CODESYS platform. And now you have access to basically all this information on a common that you would be using. The multiple options of this, you can start this with a individual device level monitoring. So let's say in your entire plant, you just want to monitor one piece of equipment and you don't have all these different tens or hundreds or thousands of systems that you're worried about monitoring. It's a single system that you would monitor. So you can certainly do that on a single system monitoring. And clearly you have a limited communication because you are simply looking at one system. And I'll explain a little bit later how we are even enhancing the single system utilization. If you are doing the fleet level monitoring that is behind the firewall, you can basically put this on an independent network. So you're not touching your critical infrastructure, and you can still do everything behind your firewall. So there is a API as well as a separate the CBM software, condition view software that is simply monitoring this information, and it can provide alerts however you configure that. So this particular diagram, it shows multiple or different systems that are being monitored. In this case, it can be a monitor, it can be a full a panel PC of some sort. It could be a handheld device. It doesn't matter. You can monitor all of these conditions. Moving on, you can also do a fleet level monitoring with a cloud-based system. And this server, it can be, doesn't have to be our server. It can be a server that is your existing IT server that is sitting somewhere in the closet. Just a few screenshots of what does this look like. So this is a like basically you start with the logging into the system, some simple dashboard. What does it look like? Well, different rails. Again, this is an example of that. If you're monitoring environmental conditions as accelerometers, fans, etc. This is a very simple dashboard, and critical thing here is that you can see it in terms of simple color coding, that it is green, everything looks good. Hey, now there is a condition where the fan has stopped working, and that is your red condition. It's an example of aux2 fan. And the fan that is not performing properly, that is, we expect certain number of RPM or a back pressure that you are not developing, then it starts to show that as a yellow condition. That is, hey, look, something is not going right. So you can take a deeper action into that. And this is where the AI modeling helps a lot. So first thing that you look at it as, hey, this is my trend, this is what it looks like. It's a snapshot of red, yellow, green. But if you monitor that over the time, then you can start looking at it and say, if there was a spike, I can say it was some abnormal condition that I don't need to worry about. But I see this trend where uh, the, uh, the trend is going negative. That's what starts to basically, the AI model starts to explain that this is leading into a failure. And you can also expand that into saying, when do you expect that failure eventually to happen, such that you can do an early intervention and schedule maintenance before it leads into a failure. And that is the most powerful thing about this tool. And that is, with the data that gets collected, you can turn that into AI model that can predict the failure. We took a snapshot of saying, with different various conditions, and this is a real life data from the field RMA returns of our systems. And we said, out of the conditions that we had seen, the snapshot of 11 such conditions, we could detect 8 of those. And that being the conditions that we could not detect is one that were not closed loop systems, such as a touch screen. Let's say the cursor is not following the finger. That is only a human interaction. It does not have a closed loop system, a feedback system, so we could not detect that. That's an example. That's another example is, let's say, LCD. Let's say there was a problem where some of the pixels have gone bad, or there is noise on the system, not able to detect it because there is no closed loop system. So those are the limitations of the system, that it does need the sensors or the closed loop system to be able to detect and to be able to collect the data, to be able to show the trend, to be able to predict the direction. And I talked about this individual system monitoring and why is it critical. So let me switch to this system here. That if you don't have a plant-wide system, and if you want to be able to really see, hey, what is happening with the system? The system has gone down, or I want to be able to look at the system and can I detect what's happening to the system? What is the status of the system? So that is where basically the system is connected to an external or to a display that is giving the QR code. Right now the picture shows barcode, but it QR code. And this QR code basically it can provide you. It's a dynamic QR code, so it will give you the status of the system at that point. And let's say the system went down because of the display that retains the previous value. You can go and scan the unit. You can scan the display, and it will give you status of the system at that point. So let's say a system went down, it will report the last known or a good or a bad condition, that this was the condition before the system went down. So you are not, your technicians are not blinded. They have a data before they even open the system or before they will start debugging. So this is one good feature that was added just for the single system application. If you are doing a fleet-wide monitoring, then this may not be necessary, or this may be necessary if you have a plant maintenance people who are walking across and monitoring the systems manually, and they can simply just go with a smartphone, just look at the QR code and figure out what the status of the system is. That could be part of their daily log or a daily check. The smartphone applications, clearly, I think it's easy to see. Everyone's quite used to using smartphones nowadays, so applications are fairly straightforward in terms of, okay, there are different serial numbers. What is the status of individual serial numbers that I have? It can be displayed very simply, red, yellow, green. We are not interested in worrying about greens. Hey, can you show me the details of a specific system? And I want to look at it. It is what is happening, and you can basically take a much deeper drill down into individual systems, specific systems. As far as the security is concerned, all kinds of encryptions we are worried about. Clearly worried about all kinds of hacking that could happen. So these are some of the security standards that are deployed or that are used to prevent any sort of a hacking that happens to the system. And as the security standards get upgraded, we'll be, of course, keeping up with it and upgrading it as and when needed and required. For the application level security, again, this is more detail of it. I will not go through each line items. Interested folks can simply go through that, and feel free to send any questions that you have in the chat before or like after the presentation, and we can certainly respond to those. Just an example of the different product line that we have. This is just focusing on industrial automation products, all kinds of computers, displays, kiosks, rack mount servers, etc. This is a snapshot, a small snapshot of the product line that we offer. I believe this is the last slide.